let's get those away. Okay, so our goals for today, in order to do our lesson today, we need to have a good handle on the logarithm rules. We also need to know how to switch between logarithmic and exponential form. So we've been working on that since the beginning. And then what we're going to be able to do by the end of today is use the log rules to solve for variables within logarithms. And then we should also understand why we can't take the log of 0 and why we can't take the log of a negative. So sometimes when we solve logarithmic equations, we get possibilities that if I were to sub them back into the original equation, I actually can't take the log of those things. So those are some things like in exponential functions when we had extraneous roots when we were solving. This can also happen with logarithms as well. So we always want to check when we're solving expressions with logarithms that if I get an answer for a variable that's inside the logarithm, that if I sub it back in, it doesn't cause me to take the log of a negative, okay? Or the log of 0 for that matter. Thank you. Okay, so we're going to solve for variables inside logarithms. One little tool that you need is that if I'm working with logarithms with the same base that are set equal to one another, I know that the insides of those logarithms must be equal, right? So essentially this is saying if I have log base 4 of x plus 1, let's say, equals log base 4 of maybe x squared, I know that x plus 1 and x squared must be equal. Because the log base 4 of something, if it's equal to the log base 4 of something else, I know that those insides are equal. Kind of like the exponents that we talked about. Okay, so that's kind of the idea. All right, so I'm going to use that idea to solve this expression here. So I have two logarithms with the same bases. What are the bases of my logarithms here? 10. Okay, so I can't quite set the insides equal to one another because of this 2 out front. Does anyone have any ideas as to what we could do with the 2? Sam?
Make the x plus 3 squared.
Yes, so I can use power rule, but kind of in reverse here. Okay, and now I have the log base 10 of x plus 23 is equal to log with base 10 of x plus 3 squared. So I know, because these both have the same base, that this must be equal to this expression. So we could say, therefore, x plus 23 must be equal to x plus 3 squared. Okay, this does not work if the logarithms have different bases. The logarithms have to have the same base for this to be true. Okay, and then my job here is to solve for x. So if I need to solve for x, I probably want to expand this x plus 3 squared out and get everything over to one side. So we're going to FOIL this expression. Okay, and I'm just going to move this x and the plus 23 to the other side of the equation, because usually when I'm solving something with x squared in it, and x's and constants, I will probably have to get this set equal to 0 on one side so that I can factor or use quadratic formula to solve this. So bringing over the x becomes negative x, and bringing over the 23 becomes negative 23. And then we're just simplifying a little bit here. Oh. What's that, negative 14, I think? Okay, so how do I solve this quadratic? What are my options? I can factor it. What if I can't factor it? What would I do? Quadratic formula. Yeah. What's that? No, you don't give up. Okay, so can we factor this? Are there two things that multiply to negative 14 and add to 5? 7 and negative 2. Yeah, I think that works. So 7 and negative 2 are our values. So what are my x's equal to here? Liam? Great. So one thing that I always want to check after I get my answers for this, these are the x's that make this expression true, right? I want to make sure that if I were to sub back in either of these x's into my equations, that I'm not taking the log of 0 or the log of a negative, because logarithmic functions are undefined for values that are less than or equal to 0. So if I sub these back in, do either of these values cause me to take the log of a negative? Well, if I sub in negative 7, let's just see here. What's going to happen over on this side?
It's going to become negative and then you square it.
But the original function, even if there is a negative in there, I have to restrict that value. So yes, because we brought this back up, in this case, it may work if I square it first, but in the original equation, I don't have that squared. So in the original equation, this is not working for us. Okay? Because this happens, we call the negative 7 an extraneous root. Okay? Does 2 cause this to happen? Well, let's check. Am I taking the log of a negative here? I'm not, right? So we can actually check our answer. We'll see if we get left side equals right side here by calculating both sides. And that's a really good way to check my answer. Okay, so you're evaluating both sides here. Is the log of 25 equal to 2 times the log of 5? What do we get for log of 25?
1.39794009.
Sorry, say it one more time. It was just
1.39794009.
Okay. And how about 2 log 5?
1.39794009.
Perfect. So these are equal. So left side equals right side, so I must have found the correct x that works there. If you tried to simplify this guy, you would find that you would get a math error on your calculator, and that's because that is not possible. Okay, that value is restricted for a logarithm. Okay, so 2 is the only permissible solution to this equation. Questions for this? Okay, let's go to the next one. All right, so the method that I just showed you is only going to work if you have log equals log. So it's essentially 2 logarithms that are set equal to one another. As soon as I throw in another term here, like this 2 is another term, I can't use the same solving process. But what I can do is, if I have logs with common bases, is I can apply other logarithm rules that I know. So right here, I have the sum of 2 logarithms with the same base. So what do sums become with logarithms? Olivia? Multiplications. So sums become multiplications. So I should be able to write these 2 guys inside the logarithm as multiples inside a single logarithm with base 6. Okay, and then one thing that we're going to need to utilize, like I have x's that are inside my logarithm right now. I'm not going to be able to isolate for these unless I switch the form that we're working with. So in order to switch between logarithmic and exponential form, we're going to use this rule that we talked about in our first or second lesson, I think it was. So if I have y equals log base b of x, I'm going to say b to the exponent y equals x. So this is switching between logarithmic and exponential form. Okay, this is a key skill that you need to be able to do in order to solve these types of logarithmic expressions. Can someone express this in exponential form for us? Log base 6 of x minus 1 times x plus 4 equals 2. Sorry?
6 to the power of 2
Good?
equals x minus 1 times x plus 2.
Awesome. Okay, so we're switching into exponential form here. Where do I go from here if I want to solve this?
You FOIL it and then put the 6 squared, 36 to the side.
Great. So we're going to FOIL. So kind of the same as where we got to above. We need to expand everything out. And then you'll see that you kind of have like a quadratic expression. So in order to solve quadratic expressions like this, we need to move everything to one side and have it set equal to 0 on the other. Okay, and I'm just going to gather that negative 36 and negative 4 all together in one step here. So I'm just moving that 36 over to the other side. It becomes negative 4 minus 36. So can we factor? Are there any two things that multiply to negative 40 and add to 3?
8 and negative 5.
Yes, that fits the bill. 8 and negative 5. Sorry?
Let's say by accident you don't find, there is something that multiplies to negative 40 and adds to 3, but you don't find it in the quadratic equation. Will you still get the right answer?
Yes, you will. Okay, so our x's are negative 8 and positive 5. Again, I need to double check in this original equation as it was given to me originally if both of these are permissible answers or not. Be mindful, just because something gives me a negative answer doesn't mean that it will be an extraneous root. What makes it an extraneous root is if I sub it back into the equation and it causes me to take the log of values that are less than or equal to 0. So we're going to do a check here by subbing back in. So we'll have log base 6 of negative 8 minus 1. Okay, and you should see a problem happening here already because this is the log of negative 9, or log base 6 of negative 9, and this is the log base 6 of negative 4. So is this a permissible answer? This is not. So we would call this guy an extraneous root. Okay, and then I can also check by subbing in 5 into my answer. For those that don't have one of the calculators where you can calculate various bases of logarithms, you're going to have to use the change of base formula to check this. So once I simplify inside the brackets here, how could I evaluate something like log base 6 of 4 and log base 6 of 14? If I don't have one of those nice calculators that gives me the option to put in bases like Sam has. How do I evaluate log base 6 of 4?
Where'd you get 14 from? Isn't it 5 plus 4?
Oh,
Yeah.
why did I put 9? What am I doing?
This,
I know. Okay, same question though. How do I evaluate log base 6 of 4 in my calculator?
log 4 over log 6.
Yes, so I'm going to use the change of base formula to evaluate this and check my work. Okay, same thing over here. Log of 9 over log of 6.
Can you combine the two so it's log 6 4 times 9?
Yeah, you could. So log base, actually that's an even better idea because log base 6 of 36 is pretty easy for us to calculate. What's log base 6 of 36? Not 6.
2. Oh.
2. So 6 times 6, I think is what you're thinking. Okay, so this is 2 equals 2. Now in the case where we couldn't do like multiples, like if I couldn't evaluate without a calculator, I would have to use the change of base formula. So x equals 5 is a permissible answer here, and we know that it's correct because we checked it back in the function. Or expression, I should say. Cool, questions? Okay, let's try a couple more. Any thoughts for how we can start this first one, or this next one here?
Can't you combine the two equations?
Yep, how would you combine, Jonathan?
So it would be log 3, and then it would be x divided by x minus 4.
Awesome. Okay, so differences become quotients. Where do I go from here? Sorry?
Can you divide out log 3?
I cannot. So that's a really good point that you bring up. Unfortunately, I can't divide out the log of a base 3 because logarithms mean nothing if there's nothing inside of them. So this log base 3 is glued to the x minus 4. Just like if I have sine of 30, I don't divide out sine separately from the angle that's in it.
Would you times it by x minus 4?
Again, I still can't do that because this is inside the logarithm, so I can't really work with the x's until I get it out of a logarithm.
E to the power of y equals x.
Where is y coming from?
I don't know, I'm just guessing.
Why we come to the 2?
So what's the base?
Base would be x over, no, base would be 3.
What's the exponent?
2.
So I'm switching into
Yeah.
exponential form.
The exponential, sorry.
The answer to any logarithm is an exponent. So if I have this equals 2, that means that the logarithm is equal to 2, which is an exponent.
So if it was like equals 4, then it'd
Yep.
be 3 to the power of 4.
Yep, exactly. Alexandra?
That's switching it to exponential form.
Yep. Okay, now I'm going to use that idea to multiply up the x minus 4. That's actually a really great suggestion. So we know that this is equal to 9. And I'm actually going to multiply up that x minus 4 because I can't really solve for x's when they're in denominators like that, so that's a bit of a problem. We're going to multiply that up and out. And I think we know how to solve something like this, right? I'm just going to expand the expression on the left. We'll get x's to one side, values to the other, constants to the other, and then just get x by itself. Okay, any questions on anything I did here?
So we only have one x instead of 2.
Yep, so that can happen sometimes. 9 over 2, this is equal to 4.5. Does this cause any extraneous roots to occur here? Like if I plug in 4.5 here, am I taking the log of 0 or a negative at all? How about here? No. So is this a permissible answer? Yes. So you guys can check if you want by subbing in 4.5 in for both of these x's, and then check that this expression is equal to 2. Okay? I'll let you guys kind of do that. I've shown you how to do it. So, okay, any questions before we move to the next? Okay, so it is possible that you could try to solve for x and you get an x value that could be an extraneous root. So we're always wanting to check if we sub back in, does this cause me to take the log of a negative or a 0? Sorry?
If you were solving the only x in this case,
That could be possible. Okay, so I'm going to give you guys a couple seconds. I want you to try 3a on your own here. See what you can solve for. Check for extraneous roots. Okay, I'm going to start putting up my solution. You guys can keep going if you're still working on this. Okay, so we do have an extraneous root here because when I sub in negative 4 back into my equation, it's causing me to take the log base 6 of negative 9 and the log base 6 of negative 4. Okay, I want to caution you guys again against just because something is negative, calling it an extraneous root, that doesn't make it extraneous if it's negative. It makes it extraneous is if you plug it back into the equation and the expression inside the logarithm itself is negative or 0. Okay, so don't automatically see a negative here and be like, oh, it's an extraneous root. You need to plug it back in and actually check to see if this is causing a math error to occur, right? Okay, usually they are, yeah, but it could happen that they're not. Okay, questions on anything that I did here? All right, let's slide over to part B. This one is a fun one. Any ideas for how I can solve this? I've got a log within a log, and the x is buried inside of this right now. So what do we do? So you're suggesting I bring this logarithm inside here? Math crime right there. Sidkey would not be happy with that math crime. Okay, I can't distribute a logarithm. Why can't I distribute a logarithm into an expression before you suggest? It's the log of x plus 2, right? Not the log times x plus 2. That's very different. So I'm glad you brought that up because that's a classic mistake that I see people make in this unit. Yes, of course you did. Sorry. Equals? Very good. Okay, so this is the inside, okay? So we're looking at the entire expression right now. The base is 9, the exponent is a half, and it's going to be equal to this. So we're changing this into exponential form. Doesn't have an exponent of 4. Has a base of 4 because this logarithm has a base of 4. Okay, what is 9 to the exponent half? It's 3. It's the same as a square root, right? It'd be 3. Okay, now how do I solve something like this? My x is still buried inside a logarithm. We're going to do it again. So how do I switch this into exponential form?
4 to the power of 3 equals x plus 2.
Awesome. So one more time, applying that exponential form.
So you're putting it from exponential form into exponential form again?
Well, this still has a logarithm in it, right? So we applied that idea of exponential form because we had a log on the outside of this, but there's still a log inside that. So if we go one step further, we can get rid of those logarithms. And then looks like we have x equals 64 minus 2. So we've got x equals 62. Okay, what we do need to check in this question is we need to make sure that 62 doesn't cause us to take the log of a negative when we put it in log base 4 of x plus 2. And then also that it doesn't cause us to take the log of a negative once that's calculated and it's inside the log base 9 of that value. So we need to check two things here. So if I sub this back in and we do a little check here, we have log base 9 of log base 4 of 62 plus 2 equals a half. And I'm just going to simplify from the inside out here. So log base 4 of 64, does anybody know how we could calculate this? I think we could calculate this without a calculator, right? 4 to what exponent equals 64? 3, okay? And then we would just need to check that, again, this is a permissible answer because we're not taking the log of a negative in either of those expressions. And 9 to what exponent equals 3? 1 over 2. So, perfect. So this is good. So 62 is a permissible answer. So we should be able to check most of our answers in this chapter by just subbing back in and simplifying and checking.
Would you have to change base for log 4, 64? Did you just leave that?
I think we just evaluated this more like guess and check kind of idea. So log base 4 of 64, we're asking ourselves 4 to what exponent equals 64. So 4 to the 3 equals 64. But if you're not sure, you could always do log of 64 over log 4 on your calculator. Okay. We're almost there, a couple more. All right, use log rules to find the value of log base a of a times b squared if log base a of b is equal to 3. Okay, so any thoughts? Actually, let me ask you this as well. Log base a of a. What is the log of any base to itself?
1.
Why 1, Jonathan?
Because if it's, because if, what's it called? The base and the output is the same, that means that, like, nothing changed.
Okay, so if I had log base 4 of 4, for instance, I would be asking myself 4 raised to what exponent equals 4? So 4 raised to the exponent 1 equals 4. So any logarithm to the base of itself, log base a of a, log base b of b, log base 7 of 7 is equal to 1. Okay, so that's good. The other thing that's important to note here is that the squared only applies to what's directly in front of it, which is the b. So I cannot, at this point, take this 2 and bring it down in front. If I had a bracket around this whole thing, absolutely I can take that 2 down and bring it in front, but I cannot do that if only one of those things has that exponent. In this case, only the b has an exponent of 2. But I do have a product in here. So what do products become? Jeremy? Products are multiplication. So the other way around, sums. Products become sums. So could I write this as the sums of these two products with bases of a? Is this okay? Okay, so products become sums. That's the logarithm rule that we're looking at here. Okay, now we just discussed this. Log base a of a, what's that equal to?
A.
No.
1. Oh my.
1. You're the one that told us about this. And I'm actually going to bring this down in front. We're going to use power rule because I know what the log base a of b is equal to. So if I have the log base a of b, I can actually substitute based on what the question is telling me, can actually substitute in its value here. But I can't do that if I have an exponent over top of the b. So I know that this is 3, which makes this exponent, this value 7. The question tells me that log base a of b is 3.
Oh, okay.
Yeah. Good, so this is equal to 7. I can't really check this one because I'm just finding what the expression is equal to. I'm not solving for an unknown x or something like that. So I would just have to check back through my work for this one. Okay, last one. We are going to need the change of base formula for this one. So just as a reminder, when I have something that is log base x to a y, I can write this as the log of y over the log of x. And I can actually choose any base that I want here, okay, as long as that base is the same. So I'm going to call that b for base. It could be a base 10. That's often what we use the change of base formula for so that I can calculate in my calculator. So it could be the log of y over the log of x. It could be the log base 5 of y over the log base 5 of x. It could be the log base 20 of y over the log base 20 of x, as long as those bases are the same. Okay? So we're going to use the change of base formula here. Does anyone have a suggestion? If I have the log of a over the log of b here using change of base formula, does anyone have a thought as to what we should or could make this base?
A.
Why a?
Because if log to the base of a and b equals 3, then we can solve the equation.
Perfect. So given our information here, I think a is a good choice for the base.
And also you can make the top part 1.
Oh, okay, perfect. And we know log base a of a is 1. Okay. And we know from the question that this is 3. So we're using change of base formula. And we're choosing the base. Again, as long as that base that we've chosen is the same, this is an acceptable way of using change of base formula. Liam? Yep. Okay, so this is equal to 1/3. Any questions for this one?
Sorry, can I see,
Okay.